You found the skeleton. How would you tell people that it's you personally? How would you decide?
Well, interesting question. I don't know. I'd have to do some research on that.
Hey there YouTube, the Dapper Dinosaur here. Today I have something new. You see, I mostly cover young Earth creationism, and usually from Christians, almost always Protestant ones too. That is in large part because at one time I was a Protestant young Earth creationist, so it's personal to me. But of course, that's far from the only kind of nonsense out there. Chances are that if you're watching my channel, you already know who Roger of Mud Fossil University is. For those of you who don't know, first, Mud Fossil University is a university the same way Prager University is. That is, it isn't one in any way except in name. If you don't know his shtick, he films his computer screen, presumably because he can't figure out how screen capture software works, stabs the poor monitor with a feather, and then simply declares rocks to be actually fossilized tissue of various kinds. For example, he seems to think that granite is ground lung meat or something. Here's an example of his more typical work.
I'm saying that was real, and there's no question they're in the statues in Egypt. I found that, and that's absolutely certain. The ribs and the lungs and all that stuff are there, so that's not even a question. Now, this is my evidence. You see this red, rusty-looking stuff coming out of here, and this stuff is like glued on there. All right, you see this red-looking stuff here. You see these dots in here. That, and I do deep research on mud fossils, and that, my friends, is two different situations going on here. That is the blood running out of the arterial. Now, you don't see the black blood because that's FeO2, and it locks itself into the veins. But the FeO3, red blood, is purged out, and here it is right here.
Of course, this statue is not a petrified real-life giant. It's the Apennine Colossus from Vaglia, Italy, which is in North Florence. It was carved by Giamologna, also known as Jean de Boulogne, a Flemish sculptor in the late 1580s. But Roger doesn't even consider the possibility that it's a statue, because he already knows that essentially all rock is petrified living things. That's just what rocks are. No, he doesn't go through the chemistry, give any reason to doubt that Giamologna carved it, or anything else like that. Just trust him, it's a real giant that someone apparently killed and posed, and then it turned into stone, somehow. But today, Roger isn't going to be talking about rocks. He's going to be talking about subatomic particles. Because you see, he's figured out that all the people who spend their whole lives studying quantum physics are badly wrong, and the standard model of particle physics is nonsense. But he's going to tell us this in the context of telling us not just how he disagrees with science, but also with Nikola Tesla, who, to be fair, was quite wrong about electrons, relativity, and particle physics generally. But we'll get into that in the video. So Roger, take it away.
Okay, my outstanding friends, this is going to be tough for some of you.
Yeah, in more than one way. First, Tesla has become something of a cult figure because he was a brilliant inventor who was unjustly overshadowed by Thomas Edison, who was less of an inventor and more of the first tech bro. As a result, there are a lot of people who think that Tesla actually secretly unlocked the secrets of the universe, but evil capitalism suppressed that because the secrets of the universe aren't profitable. In reality, those inventions of his that are not in use because they're impractical. And his work in theoretical physics was just flat out wrong in most cases. Not that he shouldn't get his due for working on things like alternating current induction motors, which in my humble opinion are way better than direct current motors, if only because they don't result in so much damn carbon dust. Have you ever tried to wash carbon dust from between your scales? I have. It's a nightmare. Anyway, back to Roger.
Everybody loves Nikola Tesla. Yes, they do. No question about it, I do too. He was a fabulous inventor, great mind, but he was not correct about the electron.
Uh-oh. I'm agreeing with Roger. I hope he says something dumb soon before reality collapses. In fact, Tesla mostly believed that electrons don't exist, and he thought that electricity was a disturbance in an ether. It's not clear to me why he thought this disturbance localized in electrical conductors, but whatever, I'm not really here to dispute or critique with a man whose theoretical work isn't really taken seriously and hasn't been for like a century. He did admit that maybe something people called an electron existed as a super rarefied plasma, which I guess he wasn't entirely wrong about. Extremely diffuse electron plasmas are a real thing, but somehow I think that while Roger is right that Tesla was wrong, he's going to correct him in the dumbest way possible, and in the process become at least as wrong as Tesla, if not more so.
And apparently, actually a friend of mine, did a video about Nikola Tesla being against the electron as is portrayed in the manuals, the scientific manuals. And I am too.
Of course he is. Why would the man who thinks that rocks are the actual remains of giants and dragons, and who apparently has never heard of the concept of a statue, meaning he can't understand 5th grade earth science, be able to comprehend postgraduate level physics?
However, it does not mean that the electron is not a particle. This claim by my friend was that the electron is not a particle. Anybody that thinks is brainwashed because they just believe what they've been told. No, I don't believe anything I've ever been told.
That's true.
I do the physical, factual evidence. I don't believe Tesla. And I'm going to tell you the truth, he wasn't right. Light is particles.
Well, light is composed of photons, which are particle-like in their interactions, but propagate in a wave-like fashion. But electrons aren't light, so I don't know why we're talking about light.
And those particles are made out of electrons.
Excuse me, the did you just say?
No. Photons are chargeless force carriers with no rest mass. Electrons are charged particles of matter with a charge of -1 and a mass of about 1.9 times 10 to the negative 34th grams. Photons have integer spin, making them bosons, which means that multiple photons can occupy the exact same quantum state, and electrons have half-integer spin, making them fermions, which cannot do the same, because of the Pauli exclusion principle. Basically, it would be hard to be more wrong than to say that light, which is made of photons, is actually made of electrons. And of course, does Roger have any experiments which overturn basically everything we know about light to make it more or less the opposite of what it really is? Of course not. And here's the thing, it wouldn't be hard to do. All you need to do is shine a laser through a really strong magnetic field, which can be generated with some coiled wire and a strong direct electrical current. If the electron, with its charge of -1, is what makes up the beam of light of the laser, and you can measure the strength of your magnetic field of your electromagnet, then you can calculate the expected deflection of a stream of electrons through such a field, and then measure the deflection of laser light onto a target when the magnet is on and off. If there is no measurable deflection beyond the error of your instruments, then the light is not composed of charged particles. And guess what? We already know it's not, because we can see light in areas with strong magnetic fields, like around Jupiter and the Sun. And while light is deflected due to the mass of those bodies, it is not deflected in any way that would be predicted for charged particles. Whereas on the other hand, things like electrons and alpha particles are indeed so deflected, which is why we have aurorae. If Roger were right about this, then it should get darker as you move away from the magnetic north and south pole of the Earth, and things like transformers should make all the light around them strobe, but none of that is true.
However, electrons are not just minus little tiny particles, they are dipoles.
I mean, electrons do have a dipole moment, or at least they should according to the standard model, but it's extremely small and to my knowledge has not been directly measured.
They're actually called Diracs, Dirac neutrinos.
Well, first, it's Dirac and not Dirac, but second, let's see if they're Dirac neutrinos. Well, the good news is that they are Dirac fermions, that is to say they have mass because of their interaction with the Higgs field via the standard Higgs boson. The problem, though, is that neutrinos are much less massive than electrons, and they are also not known to be Dirac fermions, although they might be. Currently, the source of neutrino mass, which is orders of magnitude less than that of the electron, is unknown. One possibility is that they interact with the standard Higgs boson, but only do so extremely weakly. Another option is that there is a weaker unknown Higgs boson that only interacts with neutrinos, and yet another option is that there is some unknown mechanism that gives them mass. Of course, neutrinos, unlike electrons, have no electrical charge, which is rather in the name, so even though electrons are indeed elementary particles that gain their mass via the Higgs field, and thus are Dirac fermions, they are not Dirac neutrinos, because they simply aren't neutrinos.
And they have a black and a white side, and they can actually separate.
No, neither electrons nor neutrinos have sides. They don't even take up space near as anyone can tell. They're elementary particles. That means they aren't made of smaller particles, unlike, say, protons or neutrons. Even the dipole moment of an electron, which does have directionality, only gains such directionality because of the direction of motion of the electron in question relative to an observer. If you could hold an electron still, it wouldn't have a dipole moment. Nothing about what Roger is saying makes a lick of sense, and it's flatly contradicted not by just modern super collider experiments, but like experiments people were doing in the early 20th century, and in some cases before.
And the black will congeal into a ball, and that's what black holes are. And they want the white to come to them, and the white surrounds them.
Black holes are the congealed black half of electrons, which being fundamental particles don't have halves. And here, I thought black holes were just regions of space where the gravity was so intense that the local curvature of spacetime was so strongly positive that it carved in on itself, causing space to be time-like in that it has a definite directionality, such that only motion towards the singularity is possible. But hey, what do I know? Apparently, it's the black half of an indivisible particle. So the tiny black holes that are the black half of indivisible fundamental particles wants the white half to surround them, and all of this despite the fact that neither electrons or neutrinos actually have size in the traditional sense. Fundamental particles are not objects with length, height, or width. They can't be measured with units of length. Asking how much volume a neutrino or an electron takes up can only be answered with 0, so I'm not sure what would happen if you tried to split an object of 0 volume in half. I guess since things like charge and energy are conserved in quantum mechanics, that at least hypothetically you could get 2 lower energy particles with a portion of the mass, one of which carries the original charge of the electron, but you couldn't get them to surround one another, nor would they need volume to do that. If they came back together, it would just mean they were one particle. But of course, no one has ever observed an electron split in two like this, or a dark black hole half-electron combined with a white glowing half-electron. This is not a thing anywhere outside of Roger's mind.
I'm going to show you my evidence. Now, he didn't have access to lasers and so forth. And I have access to everything he has, plus I'm sure other things that he didn't have access, obviously, semiconductors and CMOS and, diodes and all the new things that have been developed.
While I don't doubt that he has some semiconductors around, he does own a computer after all, and it's not at all far-fetched that he own a laser pointer, what I do think is outlandish is that he has a way to cobble these items together to perform experiments that are more revealing and have higher confidence than those being conducted at places like CERN, which has a super collider that's 27 kilometers in diameter. That's 16.8 miles for my American viewers. Put in the comments whether you think Roger, the man who thinks statues are real fossilized giants, can cobble together a more than 27 kilometer super collider with better instrumentation than CERN from laser pointers, computer components, and diodes which he has laying about the house. I feel like he doesn't, in part because the man can't figure out something as simple as screen capture software. He's literally pointing with a feather, like this is the Middle Ages or something. In fact, I actually don't think he has instrumentation that is as sophisticated as Tesla's. I bet Tesla had rudimentary ohm meters, voltmeters, Gauss meters, etc. Somehow, I don't think Roger even owns an electrical multimeter.
And I was in that realm. That's what I did. I was in the semiconductor industry. And
Okay, but was he doing theoretical work for future semiconductor technologies, where he'd have to learn new physics so that engineers can design new semiconductor applications? Was he one of those engineers who had to understand the physics well enough to design the new applications? I think that assuming this isn't simply a lie, he at best operated a machine in a factory that produced electronic components. Possibly something like the guy who runs the machine that puts the clear cap on LED light bulbs. Now, that's by no means a bad or unimportant job, but it's also not one that'll give you any special understanding of quantum physics. And I'm not saying that that's the exact job Roger had, just that I'm quite confident that if he did have a job involving semiconductors, it was the kind that did not require him to understand the underlying physics.
I understand this stuff very, very well.
Boy, was I wrong.
There is particles, and they are called electrons, and I'll show them to you right now, and then we'll start from there. And I can show you these particles. They knock down houses, and they burn things, and they're particles.
Are we talking lightning here? Because that's kind of true. The actual bright channel that you see during a lightning strike is plasma, which is composed of electrons on dissociated nuclei, and the high temperature resulting from the rapid flow of large amounts of charged particles can certainly add enough thermal energy to many flammable objects that they will combust. But that lightning exists and burns things isn't really enough to demonstrate that electrons exist as actual objects. You see, Tesla thought that electromagnetic energy was a disturbance in a substance that suffused the universe called ether. The ether was what the famous Michelson-Morley experiment was trying to find. You see, ether theory says that this substance, which is what light waves wave, must be everywhere. But it presumably, being a physical material, has its own particular reference frame. There must be a way one could move through the universe if there is an ether, such that the ether is stationary compared to oneself. It also follows that since Earth orbits the Sun and rotates, it should at best only be at rest compared to the ether for a single moment of time in any given year. As a result, if you could carefully measure the speed of light and then do it in different directions at different times of year, you should be able to detect the difference in the speed of light, thereby detecting the ether wind blowing past the Earth as the Earth flies through the universe. Famously, Michelson and Morley failed to find any directional or temporal change in the speed of light. This essentially falsified the ether as the medium of electromagnetic radiation. This opened the path for things like Einstein's work on quantum physics. Fun fact, the Elder Things from H.P. Lovecraft's story At the Mountains of Madness had wings primarily not to fly through the air, but rather to fly through the ether through space.
They also have a wave, but the wave is just a function of the particle's magnetic field.
No, the particle is an excitation in the electromagnetic field. So now we get into the basics of quantum field theory. Oh joy. This is not going to be a full explanation of field theory, as I'm not really equipped to do that, nor do I think it's necessary. So a field is a mathematical space in which every point can take some kind of mathematical value. Or to put it another way, contain a mathematical object. Now, theoretically, a mathematical field could carry any mathematical object. So for instance, scalar fields carry only numbers. Vector fields, you may not be surprised to learn, carry a direction, or a vector. Quantum fields tend to carry both a magnitude and some kind of directional quality, although not always a simple vector. But that's a bit too far in the weeds for now. In quantum field theory, the typical state of any part of the field is to hover around what's called a ground state. That is, the lowest magnitude of energy the field can take. A particle in this field is an excitation in which the field takes a substantially higher in magnitude value at certain points, where this point is actually not a single location, but a distribution of probabilities. The actual behavior we observe is based on a summation of all these probabilities. An electron and its antimatter pair, the positron, are excitations of what can be thought of as an electron field. The wave-like property of electrons comes from the fact that their probabilistic properties propagate by interacting with each other in a way that mathematically can be described as a wave. But to say that the electron has a wave or has a field is a bit of a misunderstanding. Now, when an electron is in motion relative to an observer, it does produce a small magnetic field. Maybe that's what Roger is talking about. Let's find out.
Let me explain exactly. And I'm going to go one by one. There's 5 statements Tesla made about the electron and why it's not as portrayed. Okay, remember this. He experimented with these particles religiously and had a better understanding on a subject than most others. Thomson, who has been given credit to discover of the electron. Well, Tesla was working with him for years and years. Now, however,
Tesla may have been a better inventor than many of his contemporaries, and I don't care to either take that position or to argue for it. I'm just saying I have no plan to contest it. But to say that he better understood the physics behind electrical phenomena is simply false. We can actually see interactions with electrons in double-slit experiments, which are done with more than one kind of particle. Usually the experiments are done with photons and electrons, which remember aren't the same thing. So if electrons didn't exist, what is making the interference patterns in electron double-slit experiments?
he said Tesla didn't believe in the existence of the electron as pictured by today's pop science. And I also know this is absolutely wrong. Science is totally wrong about the electron. I'll show you why.
Oh wow! Hey everyone, Roger has some results of his particle physics experiments showing, with what I assume will be a confidence of at least 5 sigma, that photons are electrons, which are neutrinos, and that despite being fundamental particles, they both have volume and parts. This will be wild.
But through practical reasoning and experimentation, he believed that if it could exist at all, it does so only in a perfect vacuum. That's not true.
Roger is correct here. Electrons exist all over the place, not just in a vacuum. If you've ever been shocked by static electricity, you felt the exchange of electrons between yourself and another object. And assuming that you weren't doing this exposed to the vacuum of space, it happened in a place which was full of air.
Electrons are what everything is made of. They are literally what everything is made of. So I'm sorry, Nicola, we're not going to agree on this one.
No, they're part of what normal matter is made of. Antimatter doesn't have any electrons in it. Light doesn't either. But there are many quantum fields, like the zero-spin Higgs field, and those are neither made up of, nor do they contain electrons. Electrons are simply part of the particle zoo of the Standard Model. This zoo has the half-integer spin massive particles, such as up, down, charm, strange, top, and bottom quarks, and their antimatter reflections, the electron, muon, tau, and electron, and their neutrino counterparts, as well as the antimatter versions of those particles. It also includes the integer spin particles, such as the massless gluon and photon, the massive Z boson, W boson, and Higgs boson. The bosons are also called force carriers, because they are the way that the fundamental forces of the universe communicate with particles. Of these 30 particles, exactly one is an electron.
And then he goes on to say that it would have to be a hollow sphere or a bubble. He says a bubble can exist in such a medium as a gas or liquid because its internal pressure is not altered by deformation. Well, he's saying if you throw something against a wall, it's going to pop the bubble.
What he's saying is wrong, since no one thinks of electrons as bubbles. I'm not even sure what it would mean for one to have an internal pressure. But also, Roger is betraying a severe lack of language comprehension skill here, because this has nothing at all to do with popping bubbles by throwing them at walls as near as I can tell. I don't know where he would be getting this from.
But if, as supposed, the internal pressure of an electron is due to the repulsion of electric masses, the slightest conceivable deformation, like hitting a wall, must result in the destruction of the bubble. No, that's just not true.
Again, nothing about walls, but also this bubble analogy is nonsensical. There is no internal pressure in an electron. Electrons have mass, charge, spin, and angular momentum. None of these is well described as pressure. I know that Roger also says that this is silly, but I figure I'd talk about Tesla being wrong too, since despite the hero worship he receives in some corners of the internet, he was, in fact, not an omnipotent god of science.
Now listen to this. This is where I say we should be able to get some free energy. He understood how strongly held the electron is.
First, strongly held by what? To what? What does this mean? But second, I don't think you can understand how strongly held something is if you think that it doesn't exist. It's like saying you're planning to tie up Firelord Ozai in your basement. That plan makes no sense unless you believe there's a real Firelord Ozai who could be so restrained.
It says, just to mention another improbability, the force tending to tear an electron apart.
There is no such force, since electrons, near as we can tell, have no parts. You see, we're talking about quantum objects here, and that's a word that isn't really in most people's day-to-day vocabulary. It describes things that come in quanta. A quantum shares an etymology with words like quantized and quantity. Basically, it has to do with how much of something there is. For example, electrons all have the same electric charge with the same sign. They have a charge of negative 1.6 times 10 to the negative 19th coulombs. It's not really important to know how much that is compared to charges you're more used to, but just know that it's quite small. But it's also 3 times the smallest charge possible, and all charges are an integer multiple of that value. We tend to treat the world as if it's continuous and non-discrete in most cases. For example, intuitively, the question of what's the smallest amount of water seems to have no answer, since you could always take some, but not all of a continuous substance away. But we happen to know that in reality, the smallest unit of water is the water molecule. You can't have less water than one molecule, and all collections of water are made of a discrete number of such molecules, which may change, but it is never split into fractional water molecules. Another example that you may be familiar with is in digital computing. Computing relies on units of data called bits, which can either have a value of 0 or 1. You can't have half a bit. A bit either exists or it doesn't. That's why in computing we transitioned from 8-bit systems to 16-bit systems to 32-bit systems to 64-bit systems. Those numbers are powers of 2, which is convenient, but in principle you could have a 9 or 10-bit system. But what you can't have is an 8.5-bit system. Half bits make no sense. What's half the value of a 2-value unit? What's half of a 0-bit? Is half of a 1-bit a half? Well, that doesn't help. Digital technology only reads zeros or ones. A half isn't a meaningful input or output. But just as bits can't simply be divided into subunits, similarly, the fundamental particles cannot be split into parts, nor do they physically contain smaller parts within them that could have some kind of pressure. We're at the bottom level of matter here. It can't get any smaller than this. It's physically impossible. Just like you can't have less data than 1 bit before you just get not having any bits at all. And just like you can't have less water than 1 molecule of water before you just have no water at all.
Is in pounds per square inch, represented by the staggering figure 256,899, followed by 21 zeros. That's how much energy it is required to tear apart the electron. That's what he says.
I'm glad that Tesla made up some number that would do an impossible thing, and that number was big. I guess if we're playing creationist bingo, you could mark off big number, although it's not big number therefore God, so maybe not. I don't know. There are no prizes, and it's your card. Mark it how you like in bird watching.
It's greater than the tension the tungsten wire can withstand, and yet it does not burst.
You can't put electrons under tension. They're not objects that can be grasped and pulled at like that. I have no clue why or how Tesla came up with any of this, but it seems he, not surprisingly, given when he lived, had no idea at even the basics of what an electron is. Now, by the time he died in the 1940s, he could have caught up to where science was at the time, and at the time it was already suspected that electrons didn't have parts that could contain pressure or be under tension. But for some reason, as far as I know, Tesla stuck to his guns on this one.
This is all an assumption he's making.
Yes, it would seem so.
Not even when it is hurled against an obstacle with a speed hundreds of thousands of times greater than that of a bullet. He said it doesn't burst. Well, it does burst, Nicola.
And And here's Roger to the rescue to make sure that as wrong as Tesla was about electrons, he is going to be even more wrong. Thank you for your service, Roger. You make history's biggest scientific blunders look like a simple arithmetic error in the face of your colossal, kaiju-sized inability to comprehend basically anything, or to consider that random nonsense that comes past your ears as they're lodged with the rest of your head firmly in your own colon might not be true simply by virtue that you crapped them out. Roger is part of a small group of heroes that include people like flat earthers, vaccine deniers, geocentrists, and young earth creationists, who collectively make most people significantly above average in intellectual achievement simply by dragging the average so far down because of how far below the mass of humanity they are in that area.
It breaks in half. It was a Dirac, and it breaks into its black and white component. Let's look at that now, and then we'll go forward.
So let's look at what this means. First, it's Dirac, and all that means is that electrons interact with the Higgs field, and for this reason have mass. Now, normally only neutrinos are referred to as Dirac neutrinos, and then only hypothetically, since it's not known how they gain their small mass. Second, particles that gain mass by interaction with the Higgs field are all fundamental particles. This includes quarks, electrons, positrons, etc. This means that they fundamentally cannot split in half because they don't have parts that could separate from each other. Second, if the parts that don't exist don't interact with the Higgs field, then they need to be massless. But mass is conserved or turned into energy, so I'm really excited to hear about where this mass and or energy goes, because there's a lot of it. Well, a lot of it if we're talking on the subatomic scale.
Now remember this statement, how much energy it takes to rip these electrons apart.
Okay, I'll try to remember this nonsense statement about how much energy it would take to break apart something that doesn't even have parts in the first place.
First of all, this is literally an electron. It has a dark side and a white side. Nobody ever knew about the dark side. And that is dark matter, it's gravity, it's all the things that have been missing. Now,
none of that is true. First of all, this is not a picture of an electron, but it is a way to get across the predicted differences between neutrinos and antineutrinos of two different models of how neutrinos gain their mass and how their spin behaves. The difference is complex and involves things like the behavior of neutrino spin and their interaction with the Higgs field. But suffice it to say that if neutrinos follow the Dirac model, then neutrinos and antineutrinos are distinct particles. But if they do not and instead follow the Majorana model, then the antineutrino is more of a different way of looking at a neutrino than a distinct particle. The white and black are not parts of a neutrino, less an electron. They are describing the difference between the neutrinos and antineutrinos of these two models of neutrinos. In the Dirac model, one particle is white and the other black because they have distinctly different properties. In the Majorana model, both are a gradient of black to white because fundamentally they are the same particles and have the same properties, but it depends on how you look at them. By the way, this picture is from Fermilab, and the article is in the description.
so this is what we're talking about when we're talking about those little bar magnets.
Again, no. This is neutrinos and antineutrinos. Each neutrino doesn't have a matter end and an antimatter end under either model. I'm sorry that this picture had a weird little bit joining them. I don't know why it did, but whatever. The two balls at either end of either version of the neutrino were different particles, not parts of a neutrino, and especially not parts of an electron. It's like Roger didn't even bother to read the article this is from. He simply found a picture, it fit with some wild idea he had one night, potentially while chemically altered, and then decided that, yeah, in fact, his intuition about how particles work is way more accurate than all that pesky science being done at places like CERN or Fermilab. Those guys are just too blinded by all this rigorous statistical work, data, and experimentations to see the clear and obvious brilliance of Roger's addled delusions.
Now, how do they line up together in a photon?
They don't. Photons are not electrons, or parts of electrons. They don't have mass, they don't have charge, and unlike electrons, which have half-integer spin, photons have integer spin. Exactly what spin is not really worth trying to explain at this point, but just know that subatomic particles have a property that affects how they move that is very similar in the math that describes it to the spin of classical objects, and it's called spin. Photons have a spin of 1, and one full 360-degree rotation will bring them back to the same orientation they started with. Electrons, with their half-integer spin, require 720 degrees of rotation to come back to their original state. So electrons don't have parts, and if they did, those parts wouldn't line up in photons, because electrons aren't photons. In fact, it's hard to imagine how they could be much more different.
Here's how they line up together right there.
You know, at first I thought that maybe this was some kind of image generated from a simulation of hydrogen-electron orbitals, as it kind of looks like that, but I couldn't find it anywhere, including after reverse image searches. Eventually, I spent nearly an hour digging around Roger's channel for other instances of this image so I could read the text and find it. that way. That didn't work. But eventually I found a video, now linked in the description, in which Roger tells us that this is actually from a picture from Rodney from Australia's cell phone. And it is what happens when he shines a laser through a venturi, which is basically just a tube that gets narrow in the middle. This is from extremely close-up camera artifacts, as the original image is basically just a lens flare. Roger took the image into an image editor, increased the size, and clearly did not do so by a factor that is a power of 2, introducing even more artifacting, and then just zoomed in on this picture until he found things that looked like what he wanted to see. That's all this is. There are no measurements, no controls, no statistical analysis. Just some guy he used to know shining a laser in a tube pointed at his phone's camera. Then sent to Roger so he can display how little he knows about rasterized images by introducing even more artifacts to an already low-quality image and then finding some weird significance in them.
That's the bar magnet, and there's the other side. They're both axial bar magnets. Up and there they are right there.
No, they're not. You can't image an electron with a phone camera and resolve some kind of image of it. Digital cameras have two kinds of resolution: an optical resolution and an image resolution. The image resolution is just how many pixels tall and wide the image they produce is. The optical resolution is how small an angular separation between two objects can be before the camera can no longer distinguish them as separate objects. So what's the optical resolution of Rod from Australia's phone camera? Well, most cameras have about 1 or 2 arcseconds per pixel of resolution. But let's be super generous and do what we did for the creationists and give Rod from Australia a free order of magnitude and go from the small end of the range. So we'll assume that his camera has the spectacular telescope-grade resolution of 0.1 arcseconds. Next, since I don't know the physical setup of the device, I'll be nice and say that the Venturi was set up 0.5 millimeters from the camera. And since I don't know the exact amount of scaling that Roger has unhelpfully added to this image, I'll estimate that to get this sort of gradient, it'll take at least 8 pixels. Note that the smaller pixel size and smaller distance between the camera and the apparatus will make this result more, not less in line with the camera picking up a tiny object, like presumably electrons are. This all adds up to mean that the angular size of this object, if it were in the real world, would be about 0.8 arcseconds. And such an object, viewed at 0.5 millimeters, would have a size of 2 microns. That's the size of a large bacterium. Bacteria, as you might know, are made up of many atoms, which have many electrons, which would be hard to do if the electron were the same size as the bacterium. And remember, this is being as generous as I possibly can be to Roger, including estimating in his favor by more than an order of magnitude. Now, on top of this, we're ignoring some problems with the idea of photographing an electron. You see, electrons don't just reflect light the way a macroscopic object does. An electron absorbs and emits whole photons one at a time. You can't get an image of the shape of an electron because they don't interact with photons that way. Photons hit them, they gain energy, and then emit a photon to go to a lower energy state. But this image, if it were of an electron, would have to be formed by bouncing multiple photons from the electron or having the electron emit photons from itself in distinct parts, rather than simply from a point source, which is what they actually do. In other words, it's impossible in so many ways for Rod from Australia to have captured an electron in this photograph. As for the things on the right, it looks like it's just Roger or Rod from Australia messing with the color data to get something that looks like a heat map.
Now, the black part, as I showed you, is the dark core.
You may remember that Roger showed nothing. He claimed, and his evidence for this claim is apparently gigantic electrons photographed by Rod from Australia.
These can glow and so forth, but the other one cannot.
Here's something fun. There's this thing called conservation of energy. For something to emit light, which is what it means to glow, then the energy must be leaving that thing. So unless it has a constant source of energy, it will fade. That's why light bulbs won't stay on without power running through them, and also why glow-in-the-dark paint fades after a while. In the case of the light bulb, the electrical current from a generator is producing the energy it needs to keep shedding photons. In the case of the glow-in-the-dark paint, light emitted onto the paint causes the electrons in the paint to become excited. Those electrons shed photons at a rate determined by a half-life depending on the chemistry of the paint in question. When in light, this will reach an equilibrium, but in the dark, the glow will slowly fade as electrons drop into lower energy states and emit photons, eventually going dark when all the stored energy is used up. So an electron can't just keep glowing as some kind of intrinsic property. Every time an electron gives off a photon, it has to lose energy. It can't just keep doing that forever.
The white glows and burns and has almost no mass whatsoever, and that has all the mass.
Once again, this picture is from Fermilab, and once again, Roger is either ignoring the text or he simply can't understand it. The article is short and linked in the description. Let's see what it has to say about electrons, and I'll quote it directly. Let's start with the easiest point-like particle we know, the electron, and assume it has 0 size. Although we know that the quantum realm differs from the familiar world, in which things are measured in inches and feet, we can still get a reasonable mental image of what happens as we imagine looking at an electron with a perfect microscope. To begin with, since it has zero size, you can never actually see the electron itself. However, you notice that the electron does have an electric charge and that it sets up an electric field around it. That's the first crucial point. The second crucial point is an idea called the quantum foam, which refers to the fact that empty space isn't actually empty. Matter and antimatter particles appear and disappear with utter abandon, willfully flouting what seems like a principle of common sense. Empty space is actually pretty complicated. Now, if you combine those two ideas, that there is an electric field and that space consists of a writhing, bubbling mix of particles, then you can imagine what a point particle is like. At a large distance from the particle, its electric field is weak and doesn't much affect the quantum foam. However, as you get closer and closer to the point particle, the field becomes stronger. The stronger field affects the ephemeral virtual particles to a greater and greater degree, eventually lining up other particles with its point particle. For example, the field of a positively charged point-like particle will push away other positive particles and hold negative particles close. Thus, if you collide two point-like particles, the two particles might never actually collide. The cloud of particles surrounding them will likely interact. The point-like particle is the mathematical abstraction at the center of the particle, but the extended field, in essence, makes even a point particle not so point-like. While the quarks, leptons, and force-causing bosons of the Standard Model are all currently treated as point-like, there is no guarantee that this will always be true. It may be that as we probe to smaller and smaller sizes, we will eventually find that the particles we thought were point-like are actually extended particles with smaller things inside them. However, because the core particle is surrounded by this extended cloud, determining whether the core is point-like or extended is a real challenge. In summary, extended particles have a fixed size, although they may have a fuzzy edge. Point-like particles are mathematical abstractions with zero size, but even zero-size particles have an extended effect due to the effect of the field surrounding them.
So here's what happens when light travels through. The mass particle.
And light doesn't have any rest mass, so there's no mass particle in light to speak of. But continue.
Pushes the glowy particle, which presents the field in front of it.
Again, nothing can just glow indefinitely, and further, electrons aren't two particles. They're a single point-like particle that doesn't have a defined size.
So the particle is a pair, but only this presents the field. Let me show you this actually occurring.
A physical demonstration would be wonderful, but I have a sinking feeling that we won't actually get one.
And we can actually split these apart. Normally they're attached together. That's a photon.
Okay, so wait. Are electrons photons now? So a photon is made up of a heavy part, despite photons having no mass, and also an electron, which also has mass, unlike the photon. So two massive particles, one extensive like a proton or kaon, and one point-like an electron, add together to create a zero-mass photon that's the size of a large bacterium. I don't think that was thoroughly thought through.
Remember this, and then I'll show you the rest. That's a photon, and this is what it looks like in its energetic values.
Roger says that this is energetic values, but notice how there's no key. Those colors don't mean anything unless Roger shows his work and provides a key. He's done neither.
And you can see right there, you see those little glowy spots? I don't know if you can or not. You see them right there? That bottom one is the one that's concussing. The top one's not concussing, it's losing energy.
Okay, so for these photons to be concussing, they must be affecting something with concussion, since that's what the word means. So what's a concussion? We'll ignore the medical definition, so I'll go with a hard blow or collision. So these photons are apparently colliding. Well, that's a problem since they can't collide. Photons simply pass through each other. As a rule, bosons, that is particles with integer spin, like photons and gluons, don't really interact with each other.
And then this will glow to a point where it can't take it anymore, and it'll flip to the back, and that one will come to the front. And then that one will glow, and it'll just keep spinning that way. That's why light spins.
Right, but light doesn't spin. It's not really a thing. Now, photons have a spin, but it's not actually physical rotation. Spin in photons uses math that is very similar to angular momentum in classical objects, and in the macroscopic world we all know and love, it comes out to be polarization. That is, the light has a certain kind of directionality, orthogonal to the direction of travel, and it can be filtered by the direction of spin. This is how modern 3D glasses work for 3D movies, but it's not some photons physically spinning within the photon. That would give photons an orbital angular momentum, which is another thing particles can have, but photons don't have. So again, all of this is nonsense.
It's from glowing and flipping and glowing and flipping. And I can show you that too. I have all of this very, very fully and clearly shown in all of our experiments. This is actually pictures.
I know, from Rod from Australia, and he took them with a cell phone camera, which apparently was able to pick up a photon that's 2 microns across, even though photons don't really have a size, being point particles.
Taken with smartphones, which this particular smartphone is a Galaxy S3, been years and years ago. 2014, I think they released it, 2013, something, maybe even 2012. And we've been using it. Well, Rod Warren did almost all of well, he did all of these pictures, and a couple other guys did some, but Rod did for 6 or 7 years. And it takes a long time to get it set up and get it right and get the venturi correct and get the light going the right way. It's an arduous process, and he spent literally years doing this, and nobody would pay any attention. So
it doesn't matter how hard it is to get that particular lens flare he was looking for. That doesn't make it scientifically significant. It's kind of like an ice sculpture. I've seen a lot of people do that, and I have no clue how I could possibly do it, and it looks like a lot of work. But that doesn't mean that you're going to submit their statue to a scientific journal and expect to have uncovered something new about the physics of light. What Rod from Australia did is art, not science, and that's fine. I've seen some of his pictures, and they look like cool abstract designs. The lens flare interacts with his camera sensors in interesting patterns, and that's neat. But it doesn't mean that it's new physics. For one thing, neither he nor Roger seem to have bothered quantifying anything. I have not seen any documentation about exactly how this experiment was done apart from a crude and obviously not to scale whiteboard drawing with Roger. There is no control experiment as far as I can tell. And finally, again, I really doubt that a laser, some pipe, and a Galaxy 3S beats out the Large Hadron Collider in terms of uncovering how particle physics works. One group that is better at science than Roger is my subscribers. So subscribe now to avoid being a Roger.
He's gone dark. I can't find Rodney anymore. They threw me off of Facebook, and that's where I used to be able to work with Rodney, and I lost virtually everybody that I was working with. So,
who wants to bet he was kicked off for sharing medical and or election misinformation? I don't actually know, and I don't really care enough to look into it, but I feel like that's probably what's going on here.
Rod, if you're out there, if somebody knows Rodney Warren from Australia, I'd love to keep in contact with him. I know I sort of let him down. I couldn't get this thing seen anywhere, but
it's being seen right here, right now. It's just that there's no particular scientific significance to the lens flare in some guy's Android.
You know, and I appreciate all the work he did, but I'm still pushing it, Rod. I didn't forget you, brother, and I am never gonna, man. You showed my theory was correct, and I could have never proved this without the work that you did and all the effort that you expended, my friend, and I will never forget that.
There has been no theory articulated so far. Basically, we've heard that photons are electrons, which are Dirac neutrinos, that photons are made of black holes paired with electrons, that protons are black holes surrounded by our electrons, no mention of neutrons, and no real discussion of neutrinos except to say that they are Dirac neutrinos and that electrons are in fact neutrinos. That last bit, I suspect, is the case because neutrinos come in a few flavors, electron, muon, and tau neutrino. So maybe Roger heard the phrase electron neutrino and then just thought that electrons are neutrinos? Because remember, Roger believes all passing thoughts he has about complex subjects, and never sees any reason to question his previous understanding, no matter how obviously false it may be. I also think that the reason he has decided that electrons are Dirac neutrinos is that he saw that Fermilab picture with a Dirac neutrino shown as a white and a black ball connected by some bridge. I think he saw that and decided it corresponded to his ideas about the electron, so electrons must be whatever that thing is.
Now, I'm sure he's broken down the setup and all that, and it takes literally, I don't know how many hundreds of hours it took him to get it set up in a position where we could use it. Now that all this is done, we understand now, and I understand exactly how to do it, and it is very simple. It's understanding it and developing the process that took years. But this is it. It's as simple as this. The laser shoots out the dark particles along with the white particles, the same particles here. And when they hit the venturi, only the white ones can squirt through. They're the ones that can get glowy and little big and little. The black ones are one size fits all. They cannot get through.
Except lasers shoot out only photons, which have no mass. Further, what's the size of these black particles that are stopped by the venturi? Photons are by all measures point-like particles, so there's no aperture too small for them to pass through, at least in theory. In practice, it's more complicated, but still, if you want to filter particles, the basic rule of thumb is that you have to make the openings in the filter smaller than the particle in question. Where do they go afterwards? Do they make the apparatus noticeably heavier? Do they produce black holes like Roger seems to think? I don't know, because this image is insufficient. Also, is he just hooking an alternating current power source straight to ground? That seems like a bad idea. But I also don't really know if that's what's going on, because this old scratched up picture with no labels doesn't really tell me much of what's going on.
This is ripping the electrons apart, exactly what Tesla said. And this energy should be off the charts.
It's ripping photons apart, which isn't something Tesla said, but whatever. But also, it's not ripping them apart, because as we've been assured, we have some directly imaged photons, disregarding how nonsensical that is, and they are not ripped apart according to Roger. So, which is it, Roger? Because it can't be both. If Rod from Australia's machine rips the dark particles from the light particles, then at the other end, there shouldn't be dark particles, or you've directly imaged photons, somehow.
And I'm trying to get this scene. Rod, sooner or later, my friend, you'll be noticed for what you did, buddy, and it was amazing.
Here's the thing. He won't be recognized for this because at best, it's some mildly interesting art using cameras. There are no measurements, no math to explain what's happening, not even any conceptual or theoretical work which isn't internally incoherent. It's a fine thing to want to overturn a reigning paradigm in science, but doing so doesn't mean coming in with some half-baked experiment. It means digging into the existing theory, doing actual experiments with measurements and statistical analysis, making testable predictions that differ from those of the dominant theory, and then actually showing that in experiment or subsequent observations, your predictions are right and those of the dominant theory are wrong. Some bloke down under pointing a laser at his camera isn't going to cut it.
Okay, this is Fermilab, and these are the two particles that they have seen. These are the smallest particles anybody has ever seen. Nobody's ever seen anything smaller, and they are what you would call elementary particles. So there's nothing smaller.
Yes, like electrons, photons, and neutrinos, they are point-like particles. The extensive particles, like kaons, neutrons, or protons, are made up of point particles connected to each other by the strong nuclear force, and therefore have a definable, if fuzzy, size. But this image isn't an example of two particular particles, but rather two different kinds of particle. I mean, Roger is showing the caption on screen. It says if you magnify an extended particle, it will look larger. A point-like particle will not change in size, but the more closely you look at it, the stronger the field surrounding it is. This is not two particular particles, but who cares? Roger has formed his first impression, and Roger's first impressions are infallible.
However, they're normally attached together. It's called a Dirac neutrino.
No, because neutrinos are elementary particles. A diagram showing the difference between normal and anti-neutrinos under two different possible models for neutrinos isn't evidence that neutrinos are composite particles that would have some measurable size.
And Fermilab also talks about this. And they also talk about these particles being the quantum foam. Let's see, I have another Fermilab thing here. Oh, and they also say that the standard model is the most successful model ever. It is not.
What does it mean to be a successful model in science? Well, it means to make the most accurate predictions. And how do we measure accuracy? Well, by comparing the predicted values to measured values. And when they agree with a high degree of precision, that is, with lots of significant figures, then the model is very successful. Now, I'm not going to test the claim that the standard model is the most successful, because frankly, I don't care for this member measuring contest between various fields of science about whose ideas are the best supported. However, I will say that the standard model is almost incredibly accurate in its predictions. Roger, on the other hand, has yet to provide a single prediction or measurement, never mind both. So for him to poo-poo the success of the standard model is a bit rich, to say the least.
It fails miserably.
The thing is that to say that a model has failed, you have to show where and how and to what degree it's made a prediction that did not correspond to reality. Now, the standard model does fail in certain contexts. That's how physicists know that there's still more work to be done. But that it has failed in certain extreme contexts doesn't mean it's not a wildly successful theory overall. Newton's theory of gravity is very successful, and it's more than good enough to get someone to the moon. But in extreme conditions, like when neutron stars collide, or in the case of the close orbit of the Mercury to the Sun, the predictions become noticeably inaccurate. That's why relativity was accepted. It did better. But that doesn't erase the success of Newton's theory, neither in the past nor the present.
The particle is at the heart of everything is a dipole, and that's what they're made of. This is what a proton is made of. It's not one big ball like this. It's one ball like this. At a certain number, they become stable.
No, a proton is composed of two up quarks and a down quark. It's not composed of one big thing and many small things hugging it in a shell. If Roger wants to contest that, he'll have to do a lot more than just say, nuh-uh.
And I believe it's 1823 Dirac neutrinos make 1 proton.
That seems like an oddly specific number. Let's see where he got it from. Well, the only thing I can think of is that it's close to the ratio of mass of an electron and a proton. Each proton has a mass of 1 over 1,836.5 or so proton masses. So I think Roger just looked at how many electrons it would take to weigh as much as a proton, then just decided that those protons are literally made up of that many electrons, which he wrongly thinks are neutrinos. Because again, he just looked at a picture on the Fermilab website that he didn't understand and couldn't be bothered to try to understand, and concluded that electrons are neutrinos. And so now we're in the position where protons are somehow made of electrons, which should make them massively negatively charged when we know they are positively charged.
And then they get bigger and bigger, is in these periodic zones of stability. That's all this is.
Note, the periodic table of elements isn't arranged by stable electron numbers around protons, because that's not a thing. It's based on how many protons there are. That's what the atomic number is, and that's how the chart is arranged. Hydrogen is hydrogen because it has 1 proton. Iron is iron because it has 26 protons. This is like high school physics, and it's been known for a long time. So I doubt that Roger is just too old to have been taught the periodic table and how it works. Basically, how this works has been well known since the 1920s at the latest. So unless Roger is like 110 years old, I think this information was taught to him in school.
And these are not actual particles. Every one of these has a whole bunch of isotopes on one side or the other. And all that means is that it's missing a few of these, or it has too many. That's what an isotope is. And then it will eventually go down to stability.
What you just said is one of the most insanely idiotic things I have ever heard. At no point in your rambling, incoherent response were you even close to anything that could be considered a rational thought. Everyone in this room is now dumber for having listened to it. I award you no points, and may God have mercy on your soul.
No, isotopes are defined by the number of neutrons in an atom, not by the number of electrons glommed onto the proton despite, not adding negative charge. And most elements have more than one stable isotope. For example, iron has 4 stable naturally occurring isotopes. And I'm also beginning to suspect that Roger thinks that the whole nucleus is a big black particle surrounded by electrons, and there's only ever one of these big black particles. So that both isotopes and atomic number are determined by how many electrons are in the nucleus, which I'll remind everyone is positively charged despite being composed mostly of electrons, according to Roger.
Stability is the zone right in the middle where it says, I don't want any to leave and I don't want any more to come. I'm stable. That's what stability is. If you have too many, it'll say, come on, get out of here, get out of here, get out of here. And all of a sudden, zip, they'll go. Or it'll say, boy, I'm telling you, I am lonely. I need another electron. Bip, they'll pop in there.
The most generous thing I can say about this idea is that Bader capture, where a nucleus absorbs an electron, turning 1 proton into a neutron and emitting an electron neutrino, is a thing. And so is the reverse, where a neutron turns into a proton and an electron, again emitting a neutrino in the process. But these are 2 among many nuclear processes, and many other forms of decay occur, such as spontaneous fission and alpha decay.
That's what happens in the nuclear realm. It is not just big balls like this.
Well, that's true. Atomic nuclei are made up of protons and neutrons, themselves made up of quarks. So Roger is correct that a marble is a poor analogy for an atomic nucleus. The problem is that in saying that, he's not disagreeing with any of science. No one who has studied nuclear physics or particle physics thinks that the nucleus is simply a single ball.
No, not at all. They are these.
Also no, for the reasons already given.
And when they smash these together, because they are these, they see all kinds of particles come out in the atom smashers.
Which seems like a problem for Roger. If smashing nuclei together gives all sorts of particles, then it seems like nuclei aren't just composed of electrons, which paradoxically are also neutrinos. That's what should come off when the atoms are smashed together, but it's not.
And we are using coherent light.
So light that is united or forming a whole. What does that even mean in the context of light? Are the various photons connected to each other somehow? If so, how? No one knows. It's just another smart-sounding word that Roger has heard before.
We are only using these. We're down in that realm. So we're only seeing the particles that exist of light, and they are particles, they make magnetic fields.
No, photons don't make magnetic fields because they are electrically neutral. If they did make magnetic fields, you could use electromagnets to bend light, but you can't. End of story. That's all there is to it.
And they actually can divide. So I'm sorry, Nicola, We got an issue here, buddy.
Nicola sounds like a new soft drink targeted at science nerds, or maybe a new brand of throat lozenges.
All right, we're going to just take a look at the particles that are the electrons, and then I'm going to explain to you how they're arranged in protons and so forth. We're going to see them all by themselves.
If protons are made of electrons, I wonder what Roger thinks quarks are. Does he just not believe in them? He seems to not believe in neutrons.
The electrons. But the electrons literally make up everything.
No.
Because they're dipoles. They have a black side and a part that's energetic.
I guess it's time to talk about what a dipole is, instead of just assuming people know. By the way, I'm really bad at figuring out what people just generally know by being functional adults who presumably made it past high school. A dipole is a system with two opposite poles some distance from each other. So for example, if you have a 9-volt battery, the two leads on it form an electric dipole. One end is positively charged and the other is negatively charged. Similarly, if you have a bar magnet, the north and south ends are two poles on a dipole. An electron is an electric monopole. It has no positively charged component, especially not one physically separated from the negatively charged component. Now, an electron that is moving relative to an observer will generate a small but real dipole magnetic field. But this is not intrinsic to the electron, but rather it is related to its velocity relative to the observers, since electrons that are moving are definitionally an electric current, and those produce magnetic fields. But on the other hand, when electrons are effectively not moving, such as when they are simply in a piece of metal under no voltage, there is no net magnetic field, as the dipole moment of any given electron is extremely weak, and the directionality of the dipole is essentially random per electron. These weak fields cannot add up to any measurable macroscopic dipole moment. However, if you apply voltage to induce current flow, then suddenly all the electrons have similar velocity, meaning that their dipole moments are mostly lined up and of significant magnitude when added together. This is how electromagnets work. And I'll remind you that if light were made up of particles that were electrically charged, like electrons, then the motion of light would also create a magnetic dipole, which would interact with the magnetic fields of anything else magnetic. And so light would be deflected by magnetic fields. But, well, it's not. Which means that the whole basis for Roger's idea is just observably wrong. And further, I don't think Roger actually knows what a dipole is, because the phrase an electron is a dipole doesn't really mean much without further explanation.
The dark side just is attractive, the other side is energetic. And when they get together in mass, the attractive side goes to the center. It's called a black hole. They're everywhere.
No. If the nucleus of atoms were black holes, then you couldn't get fission events, nor could you get any decay events that release particles, nor could you scatter nuclei against each other. All of this is contrary to basic observations that go back some century and a half or more.
Okay, I am sorry, Nicola was wrong. This is an electron.
No, it's an R828 permanent magnet, which is right on the screen. They're available for purchase online. They're actually magnetized neodymium magnets with a mostly nickel coating that has a bit of copper in it. They have a magnetic field strength of about 13,000 counts, making them pretty darn strong, given that they're only about half an inch or 1¼ centimeters tall.
Its negative charge was always considered, that's it, it's just negative. No.
Yes.
It is both negative and positive. It's what's considered a Dirac neutrino.
If an electron had both a positive and a negative charge, they would cancel out, because electrons, just like neutrinos, don't have parts. Mispronouncing the phrase Dirac neutrino neither makes electrons neutrinos, gives them parts, nor makes them electrical dipoles. Because Roger is here confusing magnetic and electrical dipoles, because he's an idiot who can't read. He can't even tell what he's looking at on screen, because he's looking at diagrams of commercially available permanent magnets, not diagrams of what an electron could be. And he's also conflating magnetic north and south with positive and negative electrical charges, which are not the same thing at all.
That will burn and stick, and it causes lightning and static and electricity. It's all it wants to do is find dark matter to attach to.
Oh, good. Now it's time to go over what dark matter is and why, no, electrons don't attach themselves to it. While an idea like dark matter was proposed all the way back in 1884 by Lord Kelvin, it was really the observations of Fritz Zwickly that got the ball rolling on dark matter. In the 1930s, he noticed that based on mass estimates for galaxies, the stars toward the outer edge of the galaxies were going too fast, and that the motion of all the stars in the galaxies were too uniform in speed. He proposed that some large portion of the mass of galaxies was invisible, and so it was called dark matter. Dark matter, whatever it is, does not interact with the electromagnetic force, making it hard to detect. It does, however, interact with the force of gravity, and probably accounts for some 85% of the gravity in the universe. Since then, other observations have tended to support the idea that most galaxies have large amounts of invisible but massive material associated with them, greatly increasing their mass. An example is that the gravitational lensing from distant galaxies is stronger than if the visible matter alone were the cause of all of it. So why does this pose a problem for electrons? Well, for an electron to interact with something, it must share some interaction with force carriers that the thing in question also interacts with. Well, by definition, dark matter does not interact with photons, which the electron does. Now, does dark matter interact with the strong or weak nuclear forces, which are the other two fundamental forces besides gravity? Well, we just don't know. But if it does, it doesn't do so by emitting anything that humans have ever learned to detect. So probably not. Since in the case of nucleons, which do interact with the force, they tend to give off things that are detectable, such as electrons and electron antineutrinos. But there is no evidence of such events from dark matter. Further, electrons don't interact with those forces either. The only force that both electrons and dark matter interact with is gravity. But gravity is so weak and electrons are so light that gravity barely affects an electron. So far from electrons sticking to dark matter, they would pass right through it unaltered. This is one of the troubles with figuring out dark matter. How do you study something that you can only infer exists through the weakest force, and therefore can only see the effects of at cosmic distances and with galaxy-sized collections of the stuff? You can't just get a jar of it on Earth, especially since dark matter cannot be contained in a jar, specifically because it doesn't interact with the electromagnetic force. Interestingly enough, neutrinos, which do not interact with the electromagnetic force, but do interact with the weak nuclear force, are a candidate for dark matter. But we still don't have any direct observations that I'm aware of weak interactions with dark matter. So that's still very much up for debate. Also, I should note, electrons do interact with the weak force.
That's its whole mission in life as an electron, is to find dark matter. Just like lightning goes bzzz, right to ground. Static, bzzz, right to ground. Electricity, bzzz, right to ground. If you grab a wire that has electricity in it, and it's not grounded, it'll go through you to get to the ground, and it will burn you up and electrocute you. That's exactly how powerful electricity is.
Yeah, but that has nothing to do with dark matter. Electrical ground is just a part of the electrical system with the lowest potential. It's not dark matter. It's not even really more than just a level of electrical energy that's used as the baseline for further measurements.
Now, when you put two together, back to back, you get a photon. Let's get into it deep.
So we're getting more specificity. Photons are two electrons back to back, which is odd since that would be a particle with a charge of -2 and a mass twice that of an electron, despite the fact that photons are observed to have no electrical charge and no mass. But further, what could possibly keep the electrons together? The electromagnetic force, which is the dominant force affecting electrons, would shove two bound electrons apart. There are instances where electrons can be coupled in superconductors, and weird things can happen there, but I don't think that's a good description for just everyday light, especially since, those coupled electrons still retain their mass and charge.
And spherical magnets, like the ones, if you can see those there, they can only be axial magnetized. There's different types of magnetism.
This axial versus diametrically magnetized magnet thing is literally just a description of how magnets are made in factories. Like permanent magnets that Roger is playing with on his desk. This has nothing to do with electrons per se. In factories, magnets are either magnetized along the axis of the cylinder they're made of, or perpendicular to said axis. In the first case, they are said to be axially magnetized, and in the second case, they are diametrically magnetized. Spherical magnets do not have a single definable axis, so you can't put anything orthogonal to it. So they are said to be axially magnetized. But electrons aren't spheres, they're point-like. Spheres must have a volume. Electrons do not.
There's actually I think about 5 different types. I can't remember now. I studied it a while back. But anyway, this is what we're dealing with when we're dealing with electrons.
No, electrons are not made of metal and cannot be purchased for a couple bucks a pop on the internet. Nor are they half an inch tall. I thought it was extreme when we thought that photons were a couple microns tall. Now we're getting half-inch tall electrons. I wonder how half-inch tall electrons can combine to become 2 microns across. Talk about bending space-time.
And photons. And the particles that Nikola Tesla said did not exist.
I really want to know when Roger manages to measure the strength of the magnetic field of a laser. It should be easy. Gauss meters and lasers are both easy to get, and I don't think Roger is destitute. Heck, he has way more viewers than me. I bet he could get his fans to get such things for him. Also, unrelated, but I do have an Amazon wishlist full of all sorts of stuff like RPG books and monitors and ramen and things.
Alright, they're talking about the smallest particles that exist. And I showed you The electron neutrino, which is the glowy little red one.
No, a neutrino can neither glow nor be red. Red is a range of wavelengths of light that is centered on about 700 nanometers. For a neutrino to glow, it would need to emit photons. But neutrinos don't interact with light, so they don't emit light. Never mind specifically red light. This also means you can't directly image a neutrino. You have to have it interact with something through the weak force, and then if that object emits something that does interact with the electromagnetic force, then that causes a little flash of light, which is how actual neutrino detectors work.
And the muon, which was the black one.
So electron neutrinos are red, even though they don't interact with the electromagnetic force, but muons, which do interact with it and have the same charge as electrons, are black, meaning that they don't interact with the electromagnetic force. I love how Roger understands everything so poorly that he's more likely to get everything exactly backwards than he is to say anything intelligible. It would be hard to be more stupid than this, and by that I don't mean unintelligent. I mean intentionally not understanding. Because the thing is, the text is right there. He could just read it. He could read that electron, muon, and tau particles are not the same particles as electron, muon, and tau neutrinos. He could read about the lack of electric charge of photons, or that electrons do have charge. He could read about the conservation of electrical charge, so that he could adjust his ideas to stop violating it. But instead, he'd rather just spout nonsense with no concern for actual data. And I shouldn't be surprised, as I'll remind you, this man thought that a statue carved in the 16th century was instead an actual fossilized giant. We're going to back the video up again to get his full statement. I just need to respond to electron neutrinos being red and muons being black, because that is a whole lot of crazy.
The electron neutrino, which is the glowy little red one, and the muon, which was the black one, are the only two things that exist in the universe that I can come up with.
So the entire universe is made of electrically negatively charged particles and non-charged particles. Does Roger have an explanation as to how it's even possible to generate positive electrical charge? I don't know. What's a tau particle? What's a tau neutrino? What are gluons or W and K bosons? Who knows? It's all muons and electron neutrinos, which is confusing because he also seems to think that electrons just are electron neutrinos, despite having a different charge and a different mass. I'm glad that Roger can't come up with anything else, but real scientists have come up with a lot more.
Everything is made of those two particles, and those two together actually make the electron. This is the electron neutrino portion, and this is the muon neutrino portion.
Wait, so are muons also their own neutrinos, despite again having different mass and charge? This is what happens when you just jump headfirst into diagrams and charts from particle physics without ever bothering to lay down the fundamentals of what terms like spin, charge, and mass are, without ever bothering to figure out what a quantum field is, and without ever concerning yourself with actually testing your hypotheses. You get someone who can't even speak coherently about his ideas. I'm really trying to figure out what the main idea even is. I know it's very concerned with electrons, and now I'm learning muons too, but since Roger doesn't know what neutrinos are, he keeps using the word in ways I can't figure out. I can't tell if he thinks that electrons and muons are neutrinos, or if they enter neutrino configurations, or if he thinks that neutrinos are a class of particles with some dipole element and that muons and electrons are a part of this class. It's impossible to say because he's so ignorant of all of this that he can't even express what his idea is in a way that would make sense to anyone who has even dipped their toes into this stuff. And I say that as someone who is basically just such a person. I have the most rudimentary knowledge of all this stuff, and I'm double checking essentially everything I put in these videos because I care about actually getting it right to the best of my ability. But then there's Roger, who just says whatever pops into his empty head, and for some reason, he gets hundreds of thousands of subscribers and tens of thousands of views for it. Being a pseudoscience pusher must be so easy.
Together, they were what's called a Dirac neutrino.
Nope, but we've already covered that ad nauseum, so I won't go over it again here.
And this is the part that burns, and this is the part that has mass.
Well, I don't know about burning per se. Both of them are charge carriers, so while muons tend to only last a few microseconds, at least hypothetically, both of them could transfer energy into flammable materials through current flow. But both of them have mass, and it's even on the chart he's using. The electron is listed as having 0.00511 gigavolts divided by the speed of light squared mass, and the muon is having 0.106 giga-electron volts divided by the speed of light squared. By the way, at these small masses, it makes more sense to express the masses in terms of their energy equivalent than to speak of them in terms of units of mass designed to measure macroscopic objects, like balls or pills. That's why giga-electron volts divided by the speed of light squared is being used to measure the mass of these particles.
Now, here's what their statement it says. It says the leptons are pictured as particles, and Basically, they are. At least the muon is.
No, they all are.
Now, the tau is 3,477 times as massive as the electron. And that is possible because the electron neutrino portion, I can't see any mass to it other than it just has a lot of burn. And that's what Fermilab says. I agree with what they say.
No, it's not what they say. The mass value is right there on the screen, and the part he hasn't read yet says that none of the leptons show internal structure, which means that the tau isn't made up of a bunch of electrons or electron neutrinos, because then it would have internal structure.
Doesn't anyone notice this? I feel like I'm taking crazy pills!
None of these particles show internal structure.
I'm glad he's actually read that part. I was starting to think maybe he simply couldn't read. But I'm betting he's about to simply disagree and give no reason other than nuh-uh to counter the decades and decades of careful experimentation and observation that got us to the point where scientists actually know with extremely high precision what all these particles are and what their characteristics are.
Well, yes and no. Muon, no, is actually a particle. That I can show, and I can basically prove that is a particle.
I'm going to need a lot more evidence than whatever Rod from Australia captured on his cell phone before I think that Roderick can show anything about muons, even if he's right about them, coincidentally. But I don't think I'm getting that anytime soon, and this silliness has gone on more than long enough. If you liked this video, hit the like button and tell me what you liked in the comments. If you didn't like it, hit the dislike and tell me why not in the comments. Either way, I hope you subscribe and use the bell icon to turn on all notifications so you're always notified when I have new content. I'm the Dapper Dinosaur. Thanks for watching, but before you go, I just want to say a special thank you to my channel members and my patrons, especially those pledging $20 or above. Bob Knob, Work in Progress, Ben Tovand, Tapioca Weasel, Denny5252, Ian Chen, Landon Knoll, Mabdy Babdy, San, Sphincter of Doom, The Venerable Veed, Elleran Teller, and Pat L. Dennis. As you probably know, YouTube is a very volatile platform, and from month to month my income on the channel can swing wildly. But the people you see on screen are directly supporting so that I don't have to worry too much about that, and the channel can keep going as it is, and perhaps even improving. If you'd like to join this team, there are links below to join the channel or in the description to join the Patreon. The Patreon starts as low as $1 a month, and the channel memberships start as low as $1.99 a month. On Patreon, you can even get a discount for pledging annually. If you do decide to pledge, you'll get access to an exclusive Discord server just for channel supporters, as well as early access to all of my pre-recorded videos, often up to 2 months in advance. Higher tiers will unlock even better perks. Now, if an annual or monthly pledge isn't right for you, but you still want to support the channel, there is a merch store down in the description, as well as an Amazon wishlist, just for me. And if financial support isn't something you can or want to do, then if you still want to help out the channel, please just like and share these videos and make sure you comment on them. It really helps the channel out. Thanks again for watching.